Ms. Lewis, during our investigation, we saw the 80 to 130 foot differences between the barometric altimeters and then the radio and the geometric altitudes. Would you, as a pilot, consider this amount of difference impactful to your operation?
In my experience, a difference in 80 feet or so between the radar altitude and the barometric altitude would not be cause for alarm. Generally, I'm relying more heavily on one altitude instrument versus the other, depending on what I'm doing and what altitude I'm at. So I'm generally not looking at both and trying to figure out the difference between the two, depending on what I'm doing on that particular flight.
All right, this is for Mr. Cooper, Bradham, and Rosengren, just to start. But during the ground testing of the 12th Battalion helicopters, 2 of the helicopters, the barometric altimeters were within 20 feet of tolerance. But once we were in forward flight, 100 with 100 knots of forward speed, the barometric altimeters showed errors of 80 to 130 feet. What types of errors do you believe could contribute to this 80 to 130 foot discrepancy?
Yeah, I'll start with that one, please. So when you think about all the different errors that could contribute to that, one, you have to make sure the Colesman window is clearly set correctly, and that the Colesman window actually reflects the right barometric pressure. So the flight tests you're referring to are the ones on the 15th of May, that 1 unit flight. So backing up, it's important to point out that that's really an anecdotal event. It doesn't use the standard flight test methods that the military and the FAA would use in order to characterize a pedostatic system. So there's not an independent truth measurement of barometric pressure and some of the other things that we would use here. But so in terms of the errors, one is the Colesman window. Then you have the instrument error, which is what you saw on the ground. All 3 of those aircraft were registering altimeter low on the ground, but within spec, right, for the instrument error. Then you have the position error. So 2 of the aircraft were clean, and 1 of the aircraft was ESSS. So the clean aircraft at 100 knots, you're looking at about roughly 7 feet altimeter low and position error. For the ESSS aircraft, about 50 feet position altimeter low for position error. And then you also have to correct for non-standard temperature because you're trying to compare radar altimeter to barometric altimeter. And so that wasn't a factor for the accident aircraft because the conditions were close to standard and you were low altitude. But on the 15th of May, those flights, you were flying at about 1,000 feet and about 9 degrees hotter than standard based on the aircraft OAT. That's about 36 feet altimeter low. So the combination of those factors, the instrument error, the position error, and a temperature correction, which all happen to be in the same direction, doesn't always happen that way, but in this particular case did, that if you carry that for the 3 aircraft, those errors ends up bringing you to relatively good agreement between rad out and bear out, if you compare them that way.
Thank you.
And I concur with all the statements that were made. Just one clarification, because I was involved in that ground evaluation. One of the aircraft, the right altimeter, did fall outside the Army maintenance manual check limit, so that was out of spec, and in fact, its vibrator was inoperative. So that right altimeter data would be in question for that aircraft.
Thank you. Mr. Rosengren, do you have anything to add?
No, I just, the only comment I have there is whenever Mr. Bradham and I kind of went through the data, pursuant to some of the questions I think we'll have later, I was properly educated and pleasantly surprised. We was able to get to doing the air stack ups within 1 foot of the differences, and so we'd be happy to provide that data to you in writing later.
We would definitely appreciate that. Thank you.
Yes, ma'am.
So continuing on that, and you were talking about how it is anecdotal, and we do recognize that 3 helicopters is quite a small data. It's a very small sample set. But it did line up with the existence of a possible wider discrepancy. And you have looked into that, clearly. Is there additional testing planned between the Army and Sikorsky?
So from an airworthiness perspective, we've gone back through the data, and we have airspeed calibration data for the Lima. We understand the static position error. So we don't have any flight testing planned. I'd leave that to the program office if they have other thoughts relative to that.
Yeah, no, as I mentioned earlier, I was, as initial receipt of the data from the flight test and adult flight test you mentioned, I wanted to look into it, and I asked Mr. Bradham's organization to please, let's get together and try to understand what's going on here to see if there is an issue. And again, after stepping through all of the various sources of error, and again, it's a very piece part manner, everything was within specification, minus the discrepancy we've tasked them to look into. And so I don't see any need from a safety or airworthiness perspective to do any changes for the Lima helicopter. From my perspective, I advise the colonel who advises the Army the safety of the aircraft. My perspective is this is a safe aircraft.
Yeah, and we can, if you'd like, we can talk to the difference between the recorded pressure altitude in the recorder. Yeah. Oh, cool. Thank you.
So this conversation makes me conclude that this feels like this is an inherent limitation of a barometric altimeter.
That based on all the information we've worked together and along with our Sikorsky friends, I believe this is the expected errors in an altimeter system. So when we provide that data to an air crew, there should be an expectation, as I believe they're trained to have that expectation, plus minus 100 feet or so.